The derivative of a function like this has really got, well, you've got two options. The first is that you could, considering y in this form, build a y that's based on the idea that it's 4 brackets and then go about a whole pile of wild crazy crab claws to create a fourth order polynomial. There'll be an x to the fourth term and a whole pile of other terms to gather together. That approach, okay, is fraught with danger for a couple of reasons. The first being the main being that the expansion just takes so long and it's so fraught with error. It's a big call to get that one right. So a better way to do these sort of things is to take advantage of the chain rule, which I've put over here. Now the chain rule works on the idea that you can find the derivative of y with respect to x by addressing it in two halves. And if you look closely, you've got a dy du, so we'll look at what that means in a moment, and a du dx. Now, as much as there are letters everywhere here at the moment, hopefully the pattern will become apparent as we work through these ones. So if we start out with our function, just reframing the question, clearing it up, we're going to let a variable u equal 2x plus 3. Now that variable is deliberately, the variable doesn't matter, the name is just convention, but we've chosen the thing that's on the inside bracket there as our variable u. Okay, now that means that we can then affirm that therefore y will be u to the power of 4. Now those two facts allow us to continue. The derivative of the u expression with respect to x is going to be relatively straightforward. You'll see a 2x plus 3. We need to find the derivative of 2x plus 3. And that turns out to be a relatively straightforward 2. That is to say, the derivative of the 2x is 2 and the derivative of 3 is 0. So we're just left with a 2. Now that is a derivative of u. Okay. Underneath that, we've stated that y is now going to be u to the power of 4. We're going to find dy du. That is the derivative of y, but now we're just finding it with respect to u. Okay, so in previous work we've always found the derivative with respect to x, but in this case we're going to find it with respect to u. And we follow the same old rule. It gets a bit of use, it takes some getting used to, but the answer to that will be 4u, and then we take 1 off the power. So what we did there is we brought the power down to give ourselves a 4, and we took 1 off the original 4 to get 3. What we're left with is these two very important pieces of working there, because each of them comes over here into our ultimate rule. So using the chain rule, we have the opportunity to put it all together again. The chain rule says the derivative of y with respect to x is going to be, this is where we come back over to our chain rule, which says that it's going to be the derivative of y with respect to u times the derivative of u with respect to x. Okay, substitute in. We're going to get the derivative of y with respect to u. The derivative of y with respect to u is this thing that's green there that we circled a moment ago. So that's going to go down into our working. So it's 4u. Okay. Now that gets multiplied by the derivative of u with respect to x. Oh, sorry, that was 4u cubed. That gets multiplied by the derivative of u with respect to x, which was 2. We then get 4 times u, which was 2x plus 3 to the power of 3 times 2, which will give us 8, 2x plus 3 to the power of 3. So in that case there, we've actually been able to produce a quite neat answer in a factorised form, which is far more useful. That 8 out of 2x plus 3 to the power of 3 is probably going to be a lot more useful to us than a long polynomial as our answer. This second example has a feature that is a little more peculiar than the one we just did. We have a negative power. Okay, now we're going to show that the chain rule will still operate as it did before. The derivative of the function dy dx is going to be the derivative of y with respect to u times the derivative of u with respect to x. So we need to again break this thing down into its parts. So we're going to let u equal x plus 1. So therefore we get out of that, we can rewrite the expression as u to the power of negative 4. Now I need to find the derivative of u. The derivative of u with respect to x is 1. And the derivative of y with respect to u is going to be negative 4 u to the power of negative 5. That is to say, I brought the negative 4 down to the front and I took 1 off the power. So I got negative 4 there and took 1 off the power. So we put this together using the chain rule. We will find that the process should be relatively straightforward. dy dx is going to be the derivative of y with respect to u times the derivative of u with respect to x. So we end up going back to our two significant results and put them into the equation. dy du is negative 4 u to the power of negative 5, and we multiply that by the du dx, which is 1. So we're actually going to get a relatively, the 1 is very convenient, we get negative 4 outside of u, which is x plus 1 to the power of minus 5. That's our answer. There's no real need to go any further than that. If the answer did ask for positive indices, it'd be negative 4 on top of x plus 1 to the power of 5 in that form there. So that's our derivative using the chain rule.